I'm running an experiment to see whether or not I can integrate AI into my Maker workflows to try and supercharge the process and actually get projects completed, because I've got a lot of them. So today I'm installing an AI agent called Hermes on a Raspberry Pi Model 3 B+. And this board's only got 1 GB of RAM. So there's no guarantees this is even going to work. But if it does, it tells us something important. It tells us that you don't need cutting-edge equipment to start integrating AI into your workflows. The Raspberry Pi only draws a few watts by comparison to a desktop PC, but there's a real chance that this isn't going to work. To be able to install the Hermes agent, we need to boot from USB and not the SD card. We're going to be setting up a fully headless system, and then we're going to get it on the network and accessible via its hostname, so we have an easy and reliable way of communicating with it in the event that its IP address changes. I'm going to be starting with the Raspberry Pi Imager, but instead of installing on an SD card, I'm going to install it onto a USB drive. This Raspberry Pi 3 has already been configured to boot from USB, so I'm not going to cover it here. But if enough people ask, I could probably do a walkthrough at a future time. So let's step through the Imager screen by screen and see how we configure this Raspberry Pi 3 ready to install Hermes. After launching the Imager, we select the model of Raspberry Pi we're actually using, and in this case it's a Raspberry Pi 3. Next we choose Raspberry Pi OS Other and Raspberry Pi OS Lite 64-bit. This is going to give us a minimal install because we don't need any fancy graphical user interfaces to work with this AI agent. I select the USB drive that we're going to be using as the boot media and then configure the hostname. And in this case, I'm going to be calling our Pi Gort. Yes, the AI robot from The Day the Earth Stood Still. I thought that was kind of funny. Next, I configure the username and password for the default user. In this example, I've used the Imager before, so I'm reusing some of the credentials. You may need to type these in if it's your first time round. After the boot drive is written, we just plug it in to the Pi, give that some power, and the device should start up and join the network, providing you've given it all of the Wi-Fi credentials. In this example, the Raspberry Pi OS has already configured MDNS, so I can just communicate with the Raspberry Pi using its host name followed by .local. So pinging gort.local gives us a ping result telling us that the device is online. Next, I use PuTTY, an SSH client, to log into the Pi so we can start the configuration work. Once logged into the Pi, it's time to get the configuration script, and that's available at hermesagent.neurosresearch.com. On the main screen, you can choose which operating system you're installing on, whether that be Mac, Linux, or Windows, and in our case, we're using Linux. We copy-paste the script text from the page into our terminal window and hit return, and that starts the installation process. Now, given this is a Raspberry Pi 3 with only 1 GB of RAM, this can take a little time, so be patient if you're using similar hardware. Once the installation is complete, it automatically starts up the setup script. And like a doofus, I press Ctrl+C during this process, and it cancels out the script back to the command line or jumps through to the next bit, missing out a section. So I Ctrl+C'd until I got to the command line and restarted the setup command by using the command Hermes space setup. The first thing that we configure is our LLM provider. So as you can see from the list on screen, it's quite feature rich in terms of which large language models it will actually speak to. And that includes anything that you're running locally. Remember, in our example, we're not going to be running the AI directly on the Pi. We're going to be using cloud-based models. This is really good because it offloads all of the compute power into the cloud as opposed to running it locally. But if you've got Ollama and a really decent PC running a local model like DeepSeek or something else, you can absolutely point this to that large language model and it will work just fine. I'm using OpenAI's Codex, and I follow the instructions through. And it gives me a URL to paste into a browser, whereby I log in and put in a code to synchronize my agent with my cloud account. One important thing to note here is that if you choose to use an API on a cloud-based model, you're more than likely going to be billed specifically for the tokens that you're using. And that can be significantly more than if you bundle it into a subscription like Codex. Once paired up with your large language model, you select the model that you're going to use. And in my case, I'm finding 5.4 mini absolutely fine for the work that I need to do, and it's reasonably token efficient. Once you configured your large language model, it's time to configure the chat application that you're going to use to communicate with your agent. You can absolutely use the command line, but it's a little bit easier and more convenient if you use a chat app like Telegram or WhatsApp, because not only can you use it on a mobile phone, you can actually use it when you're on the go and not even in the same workspace as your agent. In my case, I'm using Telegram. Once in the Telegram configuration, I'm choosing a manual setup, and I need to go off to the bot father to create a brand new bot and also get my user details to lock it down so it only talks to me. Next, you set up how the gateway is going to run, and that's dependent on whether you use a local service or if you're going to set it up to run manually. Typically, you want to set it up as a local service, so anytime the Raspberry Pi reboots, the gateway always comes back up. Now it's time to step through each of the tools that Hermes agent has access to. So you need to set up things like web searching, text-to-speech, image generation. There are a number of different options in there, paid and free, so select the ones that are appropriate for your use case. Once you've finished doing the setup, you can start the agent by running Hermes. And that brings you to the command line window of the agent itself. I went a little extra mile and went into Telegram and gave Gort his own avatar image, and I went on then to set up his SOUL.md. SOUL.md is essentially a system prompt for the agent, telling it who it is, what its backstory is, what its purpose is, and gives it a starting point for when you put in your initial prompt. Now, I had a few issues setting up Gort's SOUL.md. It somehow was updating a SOUL.md somewhere in the file system, but not the one that is configured for the overall agent, and he kept forgetting who he was. It wasn't until I specifically told it to update the SOUL.md in the system folder that it then figured out it was doing something wrong. From there on in, he remembered who he was. So now we have the agent set up. It's time to put the agent to work. Let's get Gort doing something cool. So I took the link to the Arduino workbench and pasted it into a chat and told Gort to configure a skill, because Gort can teach himself things. He can then go off, figure out how to interface with the workbench, and we can then start doing some programming work all directly from within a Telegram chat. Now it's time to test whether Gort can program some Arduino code and upload it to the workbench. I start by telling Gort that I use a platform I/O file hierarchy and that he needs to follow suit, so that in future, when we collaborate with a shared storage, I can open things up in Visual Studio Code with platform I/O and not have any problems. I then prompted Gort to write a piece of code for an ESP32, and I wanted to mimic the Hello World project, but with a slight difference. Previously, we did an SOS sketch, so this time, to make sure that we weren't overwriting it with the same sketch, I wanted something different. So I asked Gort to flash the LED in a countdown pattern from 5, 4, 3, right the way down to 1, with a second in between. Once it reached the 0 point, it would wait 5 seconds before looping round to flashing it 5 times again. Surprisingly, Gort went off and wrote the Arduino code and attempted to upload it to the workbench. However, it didn't really work. But that's the interesting part. Gort realized that there was an error and attempted a few different times to try and upload it, but failed each time. Kept track of all of the errors and then went back to the repo where we got the workbench from to try and figure out what was wrong. He did another attempt at uploading, and this time it worked. And I didn't prompt Gort to do that. He just went off and did it anyway. And at the end, he updated the skill in his memory so that he would know how to use the workbench in future. That's cool. So the thing that surprised me about this is that we were able to get a Raspberry Pi 3 installed with Hermes agent, and it actually worked. I was even able to use Telegram's voice dictation feature to send messages to Gort. Now, again, we're running on a Raspberry Pi 3 with 1 gig of RAM, so the transcription of that audio file took a little while, but it was successful. Yes, some things that are run locally, like compiling code, installing applications, rely on the processing and RAM constraints that we've got on this board, but this is a worst case scenario. If it works here, it's likely to work on any equipment that you've got access to, within reason. If you want to see how I set up the workbench to send the code there in the first place, check this video out here. In future, I'm going to be writing specification documents, and I'm going to be using more frontier models to plan and execute these programming challenges to execute on my projects. Can I do this in a token efficient and inexpensive way? Got some ideas on how we might do that. Until next time, have fun, be safe, and keep making.